Hello students, welcome back to today's class on integers, and today we're going to discuss the properties of integers, and in that this is lecture number 2. In the previous lecture in properties of integers we discussed a couple of properties, closure and commutative, and in today's lecture we'll try to discuss about associative and then few other properties and some applications based on all this. Right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So, the first one we're going to discuss today is all about associative property. For closure and commutative property, please refer to the lecture number 1 of the same properties of integers. Extension for that we're going to discuss about associative and other properties. So, what is this associative property? Till now, whatever the properties we have discussed are with the two numbers A and B, correct? So now let's discuss about the three numbers. Let us extend that to three numbers. So if we have three numbers and we are trying to add or subtract or multiply or divide in different patterns, let's see if those properties can satisfy equal relations. Equal means both sides it should be equal. For example, when we are talking about addition, in associative property, we are taking three numbers A, B, C. And what we are taking here, we are trying to add first two numbers, and to that resulting sum, we are adding the third one. Add the other case, add second and third, and to that resulting, add the first. Okay. So let us try to confirm whether these two are equal. In the normal numbers, we know they are equal. You can add in any way, but we'll try to discuss in respect of integers. With respect to integers means again we'll be having positive and negative numbers. So we should be very careful in that. So let us take few examples. So let me take like this: 6 plus 30 plus 5 and 6 plus 30 plus 5. Straightforward positive numbers. All are positive numbers. Okay. 6 plus 30 is 36. 36 plus 5 is 41. 36 plus 5 is 41. 30 plus 5 is again 35, and 6 plus 35 is 41, right? So 41 is equal to 41. So what I can say, when we are talking about positive numbers, all the positive numbers, yes, it is valid. Okay. But let us not try to conclude with this one. Let us also try to take some negative values. But whatever it is, from this I can say that yes, associative property is valid with addition. Right? They have associative property relation under addition. But let us not fix it for now. Let us take one more question. Let us try to discuss about that. So what is the next question? Minus 9 plus 11 plus minus 4 and minus 9 plus 11 minus 4. 11 plus minus 4. So the thing is, first we'll try to add these two. Whenever you have brackets, okay, that means that they should be calculated first. That's a group. Only after that you need to go out. Okay. So minus 9 plus 11. 11 minus 2 is 11 minus 9 is 2. 2 plus minus 4. Okay. 2 plus minus 4 is nothing but 2 minus 4. Plus into minus. Positive and negative will give you negative. So 2 minus 4 is minus 2. 2 minus 4 is minus 2. Correct? What about this one? 11 minus 4. First of all, let us try to discuss about 11 minus 4. How much is 11 minus 4? 7. 11 minus 4 is 7. So what we are getting? Minus 9 plus 7. So what is minus 9 plus 7? It is minus 2. So are these two same? Yes, these two are equal. So the numbers may be positive or may be negative. All the integers, numbers can be 0 as well. So for all these, I can say that this property is satisfied. This property is valid. A plus B plus C and A plus B plus C. Add first two and then add the third one. First add the last two and then add the first one. However you add. In addition, the order is not important. It may be natural numbers, whole numbers, integers or rational numbers. Later we will discuss about that. But in addition, no order is required. You can add in any way. You will get the same answer at the last. Right? So finally we can say that integers are associative under addition. They are associative. Associative means that relation is valid. A plus B plus C is equal to A plus B plus C. Right? Okay. So let us try to discuss the same property with negative. That means with minus, subtraction. And let us try to see if that associative property is valid or not. Okay, so the first one we're having here, A minus B minus C and A minus B minus C. What are we going to do here? We have three numbers A, B, C. We are trying to find the difference of one another. So first we'll try to find A minus B, and then we'll try to find the difference with C, or find B minus C and find the difference with A. So the point is whether these two will be equal or not, that we need to verify. So what is that we can say? Let me try to take the same example with all the negatives. Okay. So minus 9 minus 11 will give you minus 20. Minus 9 minus 11 will give you minus 20, and this minus 2. Minus 20 minus 2 will give you minus 22. Minus 20 minus 2 will give you minus 22. What about this one? 11 minus 2. 11 minus 2 is 9. Okay. Minus 9 minus 11 minus 2 is 9. So minus 9 minus 9 becomes minus 18. So now tell me, are these two equal? Are these two equal? No. Why are we getting this difference? Why are these two numbers not the same? Because we have a property, negative into negative is a positive. Negative into negative is positive. So here you can see all these are negatives. That's okay. Minus 9, minus 11, minus 2, we got minus 22. But here, minus 9 is correct, minus 11 is correct, but minus of minus 2 will give you plus 2. Minus of minus 2 will give you plus 2, and that is the difference. That is the value. That is the way we are getting minus 22 here and minus 18 here. So we can say that these two are not the same. These two are not the same. A minus B minus C and A minus B minus C. These two are not the same, right? So we can say that integers are not associated under subtraction. Integers are not associated under subtraction. Okay, so you should be very careful. These are not. Okay, so I can say that these two are not equal. A minus B minus C and A minus B minus C, these two are not the same. Okay, so it is confirmed. For subtraction it is not valid. Let us try to see for multiplication and then for division. So the same multiplication also, A into B into C and A into B into C. Let us try to apply that. Okay, so for multiplication let us try to find the product of A and B and then with C, or product of B and C and then with A. Right? So let me take a small question. Okay, so minus 9 into 11. 11 nines are 99. We have a negative. So minus 99 into minus 2. Minus 99 into minus 2 is equal to, okay, minus 9 into 11 into minus 2. The first one is 11 into minus 2. 11 2 is 22 with negative. Minus 22. Now, 99 into 2. What is 99 into 2? 99, 9 2s are 18, 9 2s are 18, 119. Okay, so 198, correct? 99 into 2 is 198. So negative into negative is again positive. Negative into negative is positive. So it becomes a plus 198. Plus 198. And this one, 22 into 9. 22 into 9. 9 2s are 18. 9 2s are 18 and 19. Yes. So this is also equal to 198. With negative into negative is again positive. So these two are equal. Not only this one, you can take any numbers, positive, negative, zeros, every number, every integer. So in associative property, multiplication is valid. That means that relation is correct. It is true. We can multiply in any order. Not only in integers, say when you take natural numbers, when you take whole numbers, when you take zero as well, when you take positive, negative, whatever the numbers, multiplication, you can multiply in any order, you will get the same answer at the end. You can multiply in any order, just like the addition. You can add in any order, right? But not subtraction. So what I can conclude here, integers are associative under multiplication. Okay, so that means associative properties are valid for integers. Integers are obeying the property of associative, right? So addition, yes. Subtraction, no. Multiplication, yes. Now let us discuss about division. Same way like this, A divided by B divided by C and A divided by B divided by C, right? So let us try to look into that. So A divided by B, first we need to find the quotient of this one, and with that you need to divide with C. First find B divided by C with that value, A divided by that value, and we need to find whether these two are equal or not. So let me take small question. Minus 12 divided by 3. 12 by 3 is 4, correct? 12 by 3 is 4. So 4 and we have a negative minus 4 divided by 2. Minus 4 divided by 2 will give you minus 2 as the answer. Let us check that here. Minus 12 divided by, this is a 3 by 2. Minus 12 divided by 3 by 2. So what we can conclude? This is equal to minus 12 into this 3 by 2 becomes reciprocal. I told you many times, if we have a fraction in the denominator, that we need to reciprocate. 2 will come numerator, 3 will go to denominator. So 3 ones and 3 6, 3 fours. So this is minus 8. Minus 2 and minus 8, we can see clearly that these two are not equal. And you may ask me one question. Sir, you took some values, it's not satisfied, but I will take another values, A, B, C, such that this is valid. Okay, you can take. You can take, but once for one set of number, if it is not valid, it is not valid throughout. If it is true, it should be true for every case. It should not be like true for specific cases. It should not be false for specific numbers, right? No. If it is true for all. But here you can see that it is not valid. So it is enough to judge or to give the statement that it is not associative. Okay. Integers are not associative under division. Integers are not associative under division, right? So let us try to keep all these 4 at once in associative. Let us try to keep all these 4. Addition we discussed. Yes, it is correct. It is being satisfied. The relation is satisfied. Multiplication correct. Subtraction no, and division also no. These two are not satisfying associative property. And these type of differences will come when you have negative and negative positive in the case of subtraction. And here, when you're dividing the fraction of fraction, so all these are things which will not be satisfied with integers, right? Not only with integers, with any numbers, these two associative property will not be satisfied, right? So let's move forward. Okay, integers are associated under addition and multiplication. For addition and multiplication is correct, but not under subtraction and division. Correct? Right. So let us try to discuss some more properties. The first one, the next one we're going to discuss is additive identity. Identity. What do you mean by identity? Simple. Let us say your ID card, identity card. What it resembles? It resembles you, right? My ID card resembles myself, my photo and my details. That means if I see ID card, it's about me. My ID card is mine. If you see in the mirror, your identity will be there, right? Identity means the same person. The same number should come again. Correct? The same thing, same. So, if we take a number and if we are additive, that means if we are adding, let me take one number 5, okay, and I want to add some number such that I should again get the same number back, same identity. I should get the same number back, right? So, what I can say here, 0 is the additive identity. Why? You know that 5 plus 0 is equal to 5, correct? Even it is also equal to 0 plus 5. It is a positive number, so you may ask me with the negative numbers. Yes, minus 2 plus 0 is equal to minus 2. It is equal to 0 plus 2. So, 0 plus minus 2. 0 plus minus 2. So, what I can say here, 0 is that number when we add to the given number, we get the same number back. We get the same identity. Identity means the same number appearing again. The same number appearing again. So, you can see here, okay, any number, even if you take 0 also, for 0 also, additive identity is 0. So, always 0 is the additive identity. Additive identity. 4 plus 0, 4. Minus 4 plus 0, minus 4. Minus 100 plus 0, minus 1000, minus 1 lakh. Whatever number it is, when you add 0, you get the same answer. 0 is nothing, right? 0 has no value. It's not, we cannot say 0 mangoes are there in my basket. That means no basket, no apples, no mangoes, correct? 0 means nothing. So when what you're adding nothing to the number, you will get the same number again. For the number 5, you're adding nothing. So the same number will appear. For minus 1000, you're adding 0. That means you're not changing anything. Same minus 1000 will come. Okay. So that is about additive identity. In the same way, we have additive inverse. You can see here, additive inverse. What will happen with inverse? Inverse means the complete value should change. The complete positive should become negative, so that these two will sum up to give you 0. Okay, see here. For the number A, if you add minus A, okay, additive, you're adding some numbers such that you should get 0. You should get 0. For the number 4, I need to add minus 4 to get the answer 0. 2 minus 2 is 0. 10 minus 10 is 0. Minus 1 lakh plus 1 lakh will give you 0. So that means the negative of the number. The negative of the number is called additive inverse. For a number A, minus A is the additive inverse. For the number minus A is the additive inverse. Understand? If I have 10 minus 10, if I have 20 minus 20, if I have minus 1000, 1000. So these two will sum up to give you 0. A plus some value minus A will give you 0. Right? 20 for number 25, you can say minus 25 is the additive inverse, not identity. Inverse means you should get the sum as 0. You should get the sum as 0, right? So for example, 30 plus 0 is 30. Minus 300 plus 0 is plus 300, right? Minus 300 plus 0 is 300, or minus 300 plus 300 will give you 0. So all these are different examples for additive inverse. Simply just change the negative. If you have negative, remove it. If you don't have, keep it. Positive number, you will get negative number. Negative number, you will get positive number. Additive inverse, not identity. Identity means identity. You should get the same number back. You should not get 0. Inverse means for a positive, you should get negative. For a negative, you should get the positive. Right? That is about additive inverse and additive identity. Next, we will go forward to learn what is a multiplicative identity. The name itself says that. Identity means I said you that we should get the same number back. But in the previous case, it is additive identity where we are adding the number. Here we are multiplying the number. So for a number 10, let us say which number I should multiply. Which number I should multiply so that I can get the same number back, same identity back. Same identity back. So what I can say, for the number 10, I need to multiply with 1. I need to multiply with 1. 10 into 1 is 10. 10 into 1 is 10. 10 into 1 is 10. Only 1, right? I can see here. 1 is a multiplicative identity. For any integer A into 1 and 1 into A will give you the same number A. Minus 10 into 1 or 1 into minus 10 will give you the same number minus 10. Your answer will not change. Your sign will not change. Same number coming again, that is called identity. Here we are multiplying, so we say multiplicative identity. In the previous class we added, there it is additive identity. Right? So you can say that, for example, it's the same kind of example we can take minus 256 into 1 or 1 into minus 256. Both will give you the same answer. Both will give you the same answer minus 256. Both will give you the same answer. Same identity will reflect back. Multiplicative identity. We discussed additive identity, which is 0. Additive inverse, which is for A minus A. Multiplicative identity, which is 1. In the same way, we have next thing called the multiplicative inverse. The next one we say it is a multiplicative inverse. Okay, before that we have additive inverse. I'm so sorry. This is not additive inverse. Okay, this is a multiplicative inverse. This is a multiplicative inverse. That means we are multiplying. Additive inverse we have already discussed. For A it is minus A. For A it is minus A. Here it is for a multiplicative inverse. For the number A, you need to multiply with some number so that you can get 1 back. In additive, it is 0. In multiplicative, it is 1. So for the number 10, you need to multiply with 1 by 10 to get the value 1. So for the number 10, 1 by 10 is the multiplicative identity inverse. Or you can also say reciprocal. The same thing is also called reciprocal. Whatever it is, the product should be 1. Okay. For number 1 by 10, 10 is the reciprocal, or 10 is the multiplicative inverse. Minus 156 into 1 by minus 1 by 56 will give you 1. The same number should come here. Right? For a number A, 1 by A. A can be positive or negative. But we don't say multiplicative inverse for 0. Do you know why? For the number 0, we need to multiply with 1 by 0 to get the value 1. But 1 by 0, is it a defined value? Is it a defined value? No. For 1 by 0 is not a defined value. For multiplicative inverse will not exist for the number 0. Okay, this is very important. Multiplicative inverse will not exist for the number 0. The question is, what is a multiplicative inverse? What is a multiplicative inverse or reciprocal of the number 0? You cannot say the answer, you should say undefined. You should give me the answer as undefined, because you don't have the answer, you don't know which answer to keep there. 1 by 0 is not a defined number, right? So you can say that for multiplicative, for number 0, you cannot find multiplicative inverse, right? For rest of every number, for A, 1 by A. For 1 by A, they are reciprocals, or you can say multiplicative inverse, right? So the next we are going to discuss about, only multiplicative inverse of 1 is integer. Multiplicative inverse of 1 is integer. Why? For the number 2, what is multiplicative inverse? 1 by 2. Is it an integer? This is an integer, but this is not integer. For minus 2, minus 1 by 2. But is that an integer? No. But only for the number 1, 1 into 1 by 1 will give you 1. 1 by 1 is equal to 1. You can say that it is again an integer. In integers, only multiplicative inverse of 1 is an integer. The rest of all the integers, you will never get an integer back. Okay. And 0, just now we discussed, 0 does not have a multiplicative inverse. 0 does not have a multiplicative inverse, right? So I think all these are clear to you, right? In the next class, we are going to discuss about distributive property of integers. Okay. Just the way we have discussed closure. Next, commutative. Let me once again discuss about these two. Okay, so that for a small recap. Today we have discussed about associative, and then we also discussed about additive inverse, additive identity, multiplicative inverse, multiplicative identity. Right? Let me tell you what are closure and commutative just for your reference. Okay. So when we are taking closure property, if you have two numbers, A and B, both are being integers. Okay, so we can say that A plus B is also an integer, A minus B is also an integer, A into B is also an integer, A divided by B may or may not be an integer. So closure property is valid for all these except for division. The same way we discussed about commutative property. Do you remember what is commutative? Commutative is again when we have two integers A and B, A plus B and B plus A. Are these two equal? As said, in addition you can add in any way. Okay, order does not matter, right? It's correct. A minus B and B minus A, are these two same? No, these two are not the same. So subtraction is not valid for commutative. A into B and B into A, as these two are equal, again for multiplication it is correct, and A divided by B and B divided by A, both are not the same, again for division commutative is not valid, right? So all this we have discussed, and in the coming class we will also discuss about distributive property. Just let me tell you, okay, distributive property. So on this we are going to cover the next lecture, right? So thank you so much, students. Stay tuned to get the next lecture. Thank you.
Hello everyone. So today we will be discussing about heat and temperature. We will be going into the basics of what heat and temperature are scientifically. Right now, you have a basic idea of heat and temperature, right? Because everyday life, nowadays because of COVID, you check the temperature every day. Yes or no? Right? So we will be going into that. So my name is Shashin Reddy. I am a graduate from IIT Dhanbad. Let's go into the class. So here, look at this. If I ask you this, what is the difference between winter and summer? There are many differences. Summer comes around March, April, winter comes around November, December, right? Many differences, right? I just gave you an example. But one of the basic examples is, we can say that winter is cold and summer is hot. Winter is cold and summer is hot. So we know what cold and what hot are. It's a feeling. We feel cold, we feel hot. Yes or no? So it's a feeling. So now, how do we define this cold and define this hot scientifically? That we will learn. Okay? Chalo. Now another simple question for us. There are two glasses of water in front of us. One is hot and the other is cold. How can we know which is which? I mean, how can we know which glass is cold and which glass is hot? That is, if I say this is glass A, this is glass B, so how do we know which is cold and which is hot? Now, let's say it is not very hot, it's not very cold. Okay, then it's very simple, we can touch it. By touching, we can say one glass, let's say this, it is hot. So when you touch the glass, you will feel hot. But when you touch this, let's say the cold glass, you will feel cold. So hot or cold, you can tell them by touching the glasses. You can tell that by what? Touching the glass. So touch can be a useful tool to understand whether a given object is hot or cold. So we can say that by touching it. Okay, that's good. But is it always reliable? That means by touching, can you always tell how hot an object is? Let's look into it. Okay, so first of all, we'll learn about something called as heat. Right, now see, when we touch a hot object, we feel hot. When you touch a cold object, we feel cold. Now what happens is, if this is a hot object, and if I am touching the hot object, if I touch the hot object, what happens is heat will flow. Heat is a form of energy. So heat will flow from the hot object, into our hands when I touch it. Into our hands when I touch it. Yes or no? Just a minute. Right? But the same thing when I touch a cold object. When I touch a cold object, what happens? Heat will flow from our hands. We will lose heat. That is the reason why we feel cold, from our hands into the cold object. So the main point is, when I talk about heat, I am talking about heat that flows. Heat will flow. Heat will flow. So heat, how do you define heat? Heat is a form of energy which flows from a hot body to a cold body, always. See, when I am touching a hot body, it is flowing from the hot body to us because we are comparatively cold. But when I touch a cold body, who is hotter? The cold body or us? We are. So when I touch a cold body, from our body, heat flows into the cold object. So what is that? Heat is a form of energy. Very important. This is the definition. Heat is a form of energy which flows from a hot body to a cold body. Or else, we can also define heat in this way: the energy which makes an object appear hot or cold. Yes or no? Because how do we feel hot or cold? It depends on how the heat flows. If the heat flows into our body, what is that? See? Heat flows from the object into our hands, it is hot. We get, if heat enters us, that object is hot. But if heat goes from our body to the object, that means it is cold. So heat is what makes it appear hot or cold. So heat can also be defined as the energy which makes an object appear hot or cold. In simple terms, one important thing that you have to understand is heat is a form of energy. Heat is a form of energy. Any definition, you have to mention that. Heat is a form of energy. Now, what are the other types of energy that you might have heard of? Energy from the sun, solar energy. Energy from light, light energy. Energy from sound, sound energy. So there are different types of energy. Again, in fact, energy from food also. Energy in chemicals, chemical energy. Energy in current, electrical energy. So there are different forms of energies. One form of energy, one type of energy is heat. And where does heat energy occur? Heat energy flows from a hot body to a cold body. Okay? Good. That's good. So you can clearly see the body that gains heat. Gains will mean it gets heat. So that gains heat becomes hotter, and the one that loses heat becomes cooler. Clear? Again, the third point is also an interesting one and an important one. So that is heat. Heat is a form of energy. Now there comes something called as temperature. What is temperature? We'll understand. But before that, let's go into this. Have you anytime touched a bulb? We are taking an incandescent bulb. These are the old type of bulbs, the orange bulbs. So have you touched an incandescent bulb anytime? I mean, obviously when it is glowing. Or let's say you have switched on the bulb for some time, switched it off, and then you are touching it. The bulb will feel hot, yes or no? If you touch the bulb, you will feel that it is hot. Okay. Then I'll go into this. Have you touched a pot of boiling water? So here you have an incandescent bulb. Then here you have a pot of what? Pot of boiling water. So when you touch the bulb, you will feel hot. You will feel that the bulb is hot. When you touch the boiling water again, then also you will say that the boiling water is hot. By touching, you can tell whether an object is hot or not. Now the question is, which is hotter? The question is, which is hotter? The boiling water or the bulb? The bulb that is glowing. Which one is hotter? Right, now that, how do we say? See, if I touch this boiling water, I'll feel hot. If I touch this, I'll again feel hot. But I cannot say which is hotter only by touching. No, very difficult. So in that case, or for those purposes, we define temperature. So using temperature, we can say how hot an object is or how cold an object is. Okay, temperature is a measure of hotness or coldness of a body. Nowadays, when you go to, let's say, any shopping mall, any place outside, they measure your temperature. Yes or no? They use a thermometer to measure temperature. Your temperature might come around 98.6 degree Fahrenheit, 99 degree Fahrenheit, normal temperature. But if your temperature is 100 degree Fahrenheit, you have a fever. 100, 101, 102, very high fever. Yes or no? So as temperature increases, your fever is more dangerous, more drastic. Yes or no? So why do we use temperature there? To measure the hotness of the body. So temperature is a term, is a quantity that we use to measure how hot or how cold a body is. To measure the hotness or coldness of a body. So understand, heat and temperature are completely different. Heat is a form of energy that will flow from a hot body to a cold body. But how much hot a body is, how much cold a body is, we tell using temperature. Got it? So temperature measures how hot a body or how hot a body is or how cold a body is. Clear? Good. So to measure which is hotter here, we can use a thermometer, measure its temperature, then we can say which is hotter. Not by touching it. By touching we cannot say exactly, but using a thermometer or by measuring their temperatures, we can exactly say which is hotter. Okay? Good. Let's continue. Now the question is, we learned about temperature. We learned its definition. We learned what it means. Then how do we measure it? Now we'll go into that part, the measurement of temperature. But before that, let's go into something. Now, when we measure height, generally, in which units do you measure height? Yeah? In which units do you measure height? We can measure it in terms of centimeter, Generally that happens. Generally we measure in terms of centimeter or in terms of inches. Foot and inches, right? 6 feet. Or you can say 4 feet, 3 feet, 4 feet 5 inches, 3 feet 10 inches, 4 feet 6 inches. Yes or no? Or 2 feet something. So we measure height, we can measure height in terms of centimeter or in terms of feet and inches. Yes or no? Right? So simple, I have mentioned the point. Now here for height, measuring height, we have different units. Similarly for temperature also we will have different units. For temperature also we'll have what? Different units. And for every unit we define a scale. You'll understand what scale is. As of now, understand it as different units. So for temperature, what are the units or what are the scales? For temperature, you have the basic one, the Celsius scale, the Fahrenheit scale, and the Kelvin scale. You have 3: Celsius, Fahrenheit, and Kelvin. We'll go into each and every one of them, then you'll understand them very clearly. Okay. So before we go into Celsius, Fahrenheit, and Kelvin scale, let's understand a few points. Let's go into something called as boiling point of water. Now what is boiling point, everyone? We say water is boiling, but what is boiling? The boiling point or the phenomena boiling is the conversion of water into water vapor, into steam, into a gaseous form. Yes or no? So the temperature at which water converts into steam is called as what? Is called as the boiling point of water. And what is the boiling point of water? It is 100 degrees Celsius. But the same thing in different units. I told you, right, there are different units. So it's like my height in centimeter is 178 centimeter, but in terms of inches, I'll just give an example. Okay, my height is 178 centimeter, or the same thing in terms of inches is, I think it is 5 feet and 10 inches. Okay, 5 feet and 10 inches. So if I look at this in centimeter, there is a different number. In feet and inches, there is a different number. Yes or no? So depending on the units, there will be different numbers. So there are different units. This is called as degree Celsius. The boiling point is 100. In terms of degree Fahrenheit, it is 212. In terms of Kelvin, it is 373. So different units, you have different numbers, different values. Okay? Good. So similarly, you have something called as melting point. What is melting point? We say that ice melts. What happens when ice melts? Ice will be converted to water. Yes or no? So when we say melting point or the phenomena melting, we are talking about conversion of ice into water. Generally speaking, solid into liquid. So the temperature at which ice converts into water, is called the melting point of ice. And do you know what the temperature is? The temperature is in terms of Celsius 0, in terms of Fahrenheit 32, in terms of Kelvin 273. Those are some values that you have to remember. We'll go into those values, don't worry. Okay, but that's melting point and boiling point. Melting point of ice and boiling point of water. Clear? Okay, that's good. That's good. Let's continue. So now we'll go into the units of temperature. We'll first start with Kelvin. Now why are we starting with Kelvin? Because the SI unit of temperature. The SI unit of temperature is Kelvin. The symbol is capital K. Now you might think, sir, normally I have heard about Celsius, I have heard about Fahrenheit. What is Kelvin? Kelvin is mostly scientific. Okay, in everyday life we use Celsius and Fahrenheit, but Kelvin is the proper unit and it is the SI unit of temperature. It is the SI unit of temperature. And Kelvin is the name of a scientist, a very famous scientist. Okay, that is the reason why its symbol is capital K. Got it? Now we have other units also. See, for Kelvin, the symbol is capital K. For Celsius, we have what? Degree Celsius. Do not forget this degree. This is important. When you write it down, the degree is very important. For Kelvin, no degree. It's a very important thing. For Kelvin, we have no degree, but for Celsius and Fahrenheit, there is a degree. So degree Celsius, degree Fahrenheit. So these three are the most used units. Kelvin SI unit, degree Celsius and degree Fahrenheit, other units which we use regularly in our everyday life. Okay, good. So I'll start with degree Celsius. So for every unit, you have to understand this. The melting point and boiling point. Okay, it is something that is defined. Okay, now the Celsius was also is name of a scientist. Okay, Celsius is also a name of a scientist. So this scientist Celsius, he thought, there is melting point of ice, there is boiling point of water. So melting point, I'll take the temperature as 0. Boiling point, I'll take the temperature as 100. And he equally divides the temperatures between them. So it's like a scale. It is like a scale. See, just a minute. So if I take a scale, you can take a 15 centimeter scale. At one end you have 0. At the other end you have 15. And then you're equally dividing the length of the scale into how many parts? Into 15 parts. Yes or no? That's how a scale will be. Let me again draw it. If this is a scale, this is 0, then 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, 9, then 10, 11, 12, 13, 14 and 15. So we take the length of the scale and we are dividing it into equal parts. And how many equal parts? 15 equal parts. So we are dividing the length. Similarly, for us, we are dividing the temperature between the ice, the melting point of ice and the boiling point of water. Into how many parts? 100 equal parts. Like 100 minus 0, that's it. Just subtract 100 minus 0 is equal to how much? 100. So you divide that into 100 equal parts. That's it. Okay, that's what Celsius has done. Now, Celsius took melting point of ice as 0, boiling point of water as 100. Now you might say, sir, I will define a unit. I'll take melting point as 10. I'll take boiling point as 50. Can I do that? You can do it. You can call it by your name. Okay, you can do it. But regularly or the standard ones are this. Celsius is one of the standard. Where melting point of ice is 0 degree Celsius. Boiling point of water is 100 degree Celsius. And how many parts do we have in between? 100 minus 0, 100. Number of divisions between the melting and the boiling point of water, 100 minus 0, it is equal to 100. Clear? Understood? Okay. Now you might ask me, sir, why did Celsius, the scientist Celsius, take the melting point of ice as 0? It was up to him, he decided it. Why did he take boiling point of water as 100? It was his choice. Okay. Then you have Fahrenheit also. Fahrenheit again. Fahrenheit is also a name of a scientist. But we call it as degree Fahrenheit. So according to Fahrenheit, what did he do? He took the temperature of melting point of ice as 32 degree Fahrenheit. How much? He took the number as how much? 32. I told you, right? It's up to us. So it was up to Fahrenheit. He took it as 32. And boiling point, they took it as 212. And how many parts is it equally divided into? You have to subtract 212, the boiling point of water and the melting point of ice. 212 minus 32. Do it, everyone. Subtract 32 from 212. What will you get? 32 from 212, you will get the value as how much? 180. 180, 212, 32, subtraction 2 minus 2, 0. You have 1, 3. So 11 minus 3, 8. 2 becomes 1, 180. Clear? So that's the thing. You can just say 212 minus 32 is equal to 180. So the melting point of ice 32 degrees Celsius, 32 degree Fahrenheit. The boiling point of water 212 degree Fahrenheit. And the number of divisions between them, how many is that? 212 minus 32, 180 divisions. And do not forget that for Fahrenheit, you have to take it as degree Fahrenheit. Degree Fahrenheit. Very important. Degree is very, very, very important. Okay. These are some things that we have to remember. No option. Okay. For Celsius, melting point of ice is 0. The boiling point of water is 100. For Fahrenheit, the melting point of ice is 32. The boiling point of water is 212. You have to remember. Okay. Then comes Kelvin scale. What about Kelvin? Again, Kelvin is also name of a scientist. So what did Kelvin do? He took the melting point of ice as 273 Kelvin. I think, sir, where are these random numbers coming up from? There are reasons behind it, but very complex for us. For now, you can assume that Kelvin just took the melting point of ice as 273 Kelvin and he took the boiling point of water as 373. How many equal parts are there? How many divisions are there between melting point of ice and the boiling point of water? Everyone try doing it. How many divisions are there between these two? Right, for that you go for 373 minus 273. 373 minus 273. How much will that be? Yeah, that will be 100. So you divide the temperatures between melting point of ice and the boiling point of water in Kelvin scale into how many parts? 100 equal parts. You can write it down here. 370 minus 273 is equal to 100. So melting point of ice 273. The boiling point of water 373 Kelvin. Ultimately, everyone, you have to remember this. Is there any now many of you might be thinking, sir, is there any logic behind these numbers? There is, but very complicated for us at this stage. We will learn it in higher grades. For now, please remember this. Okay. So you have different units. You have degree Celsius, degree Fahrenheit, you have Kelvin. And for different units, we have different values. So these are scales. Units are different. And when we say Kelvin scale, its importance is this, melting point and boiling point. When you talk about Fahrenheit scale, then its importance is melting point and boiling point will be different values. Okay, different scales, they define melting point and boiling point as different. Clear? Okay, that's good, that's good. So let's go into a few questions then. What is the best way to know how hot something is? I'm talking about how hot something is. By touching it, by seeing it, by measuring its temperature, or any of the above. What do you think is the answer? What is the best way to know how hot something is? A, B, C and D. Yeah? The correct answer is, yes everyone, all of you are correct, that's wonderful. By measuring the temperature, option C. By measuring temperature. Good? Wonderful. Next. Which of the following is not a scale of temperature? Celsius, Fahrenheit, Kelvin, thermometer. Which of the following is not a scale of temperature? What do you think? The answer is thermometer. We have different units. We have Celsius scale, Fahrenheit scale, Kelvin scales. We have their corresponding units also. But thermometer is an instrument to measure temperature. So the answer is thermometer. Clear? Next question. What is the boiling point of water equal to? 100 degrees Celsius, 212 degree Fahrenheit, both A and B, neither A and B. What is the boiling point of water equal to? This is an interesting question. What do you think is the answer? Option A, option B, option C and option D. Yeah? The correct answer is option C, both A and B. See, boiling point of water. We have different values in different scales. Different values in different scales. Yes or no? Is equal to, in Celsius, 100 degrees Celsius. In Fahrenheit, 212 degree Fahrenheit. In Kelvin, 373 Kelvin. Got it? Good. Next, what is the melting point of water? Again options. 100 degrees Celsius, 212 degrees Celsius, 270 Kelvin, 32 degrees Celsius. So what is the melting point of water? Again, A, B, C and D. What do you think is the answer? What is the melting point of water? And the answer is option C, 273 Kelvin. Because when again, see, you have to remember the values in every scale, in every unit. So when we talk about melting point of water or ice, okay, then it is equal to 0 degree Celsius. Or in terms of Fahrenheit, 32 degree Fahrenheit. In terms of Celsius, 0. In terms of Fahrenheit, 32. And in terms of Kelvin, 273 Kelvin. That is the reason why it is option C. Okay. So that's it, everyone. So in today's class we learned about heat. What is the definition of heat? What is heat? Heat is a form of energy that flows from a hot body to a cold body. How do you measure how hot a body is or how cold a body is? Using temperature. Temperature is a measure of the hotness or the coldness of a body. What are the units that we use for temperature? We use degree Celsius, degree Fahrenheit and Kelvin. We learned about the melting point of ice and the boiling point of water also in different units. Okay, so please go through that, please revise them and please remember the values. Okay, thank you everyone. Thanks a lot.